welcome everybody to this, which is the 7th WasmEdge community meeting. And we're going to kick it off this time around. We've got Sam, who's going to do a Rust SDK preview for us. And following that, Michael's going to do running the Rust SSR function in WasmEdge. And Heide is going to give us a WasmEdge 0.10.0 preview. So that will be really interesting. Looking forward to all those. All right, so welcome everybody. Let's kick it off. Sam, whenever you're ready.
Hi, guys. My name's Sam. Actually, my Chinese name is Liu Xin. Actually, I know my name, Xin, a little bit hard for English speakers to pronounce it. So just call me Sam. And I'm responsible for WasmEdge Rust bindings. So in this meeting, I would like to introduce to you guys some the major changes happened in the latest version of WasmEdge C-Crate. And then I'll talk about our plans for the future work. So first, let's see the optimizations we made in the latest version of WasmEdge C-Crate. In the previous version, namely 0.4, we provided the thread-safe support at the level of objects. And based on this support, we made a further step to optimize the object design and brought about a better ownership management. For example, we use a consistent and much finer-grained way to manage the lifetime of a Rust object that works as a safe wrapper of a raw pointer. Second, we optimized some of the APIs published in the previous version, and also simplified the implementations of part of the APIs. In this work, we borrowed some ideas from the best practices in the Rust language community, and in the future development, we'll continuously optimize our APIs based on the feedback from our open source community, and also the best practices in the industry. As for the test cases, we optimized some existing test cases and also designed some new test cases to cover more general cases, and also some corner cases. For now, there are still a lot of work to do in our test design. For example, our current test design mainly focuses on covering the major features. For example, whether an API can work correctly or not. In future versions, the test design will go in deeper from coarse-grained design to, I think, much finer-grained cases, and we'll also cover more corner cases. Okay, the second interesting thing happened in the latest version is thread-safe host function. In the previous version, we introduced the thread-safe design, but there's still a piece of puzzle left in the in that version. That is related to the thread-safe host function. In the original design, the host functions are managed via the thread local mechanism, and the typing is also non-thread safe. So in this, I mean the latest version, we replaced the local thread local macro with lazy static to solve the first issue. For the typing issue, we used the atomic reference counting and locker mechanism. And at the same time, the host function type is declared to implement send and sync cheats. The third thing we did in the latest version is we spent a lot of time refining our API documentations. For example, we kept the keywords in the same doc style and fixed some bad links and typos. Okay, in this page, I would like to share some ideas about our future work of our Rust bindings. The first thing is about WasmEdge CIS. First, we are now working on a new version of WasmEdge CIS that will be based on the new version of C APIs. With some great changes of C APIs, the next version of Rust WasmEdge CIS will bring some big changes, I think, in the architecture and also APIs, including like a new module instance and some changes on function call. Another hard requirements in WasmEdge CIS is about the async APIs. We plan to provide the support for async APIs maybe in version 0.7. And the second crate is WasmEdge RS. Another important work we've been working on is the WasmEdge RS crate, different from CIS crate. I mean, just WasmEdge CIS crate. This crate provides high-level APIs for Rust developers. And these APIs are much better and more friendly for application developers when they want to build some interesting business logic. And we've already finished most of the work of the first version of WasmEdge RS crate. So we will publish it maybe in the upcoming weeks, I think, maybe 1 or 2. Yeah. The third thing is about WasmEdge tabs crate. The motivation of introducing this crate is to simplify the design of WasmEdge CIS and also WasmEdge RS by extracting some commonly used data structures or tabs. So it can be seen a collection of data structures. This crate is used by both WasmEdge CIS and also WasmEdge RS crates. Also, I think it could be also useful for some future development and also maybe just becomes larger because it's just designed to just to be a how to say data structure crate and just collect some common things like to construct WasmEdge RS, the future version. I mean, yeah. This is all I would like to share with you guys. So maybe you have some questions. Yeah. Thank you.
Awesome. Thanks, Sam. That's really
great.
great.
This is my first time to share my work, so a little bit of nervous.
No, you did great. That's really excellent. Thank you so much. That's really interesting. If anybody has any questions, we do have a section at the end, and we go ahead and have some questions and answers. And so people might hit you up at the end, Sam. I've actually got one at least. So that was excellent. Thank you so much, and very interesting. All right. So yeah, stick around and we'll get some questions to you at the end. Okay. So next on the agenda, we're going to go over to Michael. And as I said, he's going to be talking about running the Rust SSR function in WasmEdge. So take it away, Michael.
All right, thanks, Tim. And by the way, Sam, excellent job. That's we appreciate that. And let me share my screen. Okay. Yeah. So everybody can see that, right? There's a not secure website on this screen.
Yeah, we can see it.
Okay,
can see it.
Excellent. Yeah. So what Sam has described is using embedding WasmEdge into a Rust application, right? So you have a Rust application and you want to create extensions for it. And so what you do is that you use the SDK to embed a Wasm application, a safe application, into the Rust-based host application, right? That's the primary use case for the Rust SDK. So I want to switch gears to talk about something that we have been working on the other end, is to write fully featured Rust applications and have them run inside WebAssembly, so that essentially using WasmEdge as a server, right? Using WasmEdge to serve up web pages like Apache Tomcat, so if you will, right? So the question that we always got is that why would you want to do that, right? Isn't this, or can't you do that with Java or with Docker? That's there's lots of tools out there to do that, and one of the most compelling use cases that we have seen, I think we talked about that in the past, is server-side rendering. It's so the idea is that I think in the past 2-3 years, there's a very big shift in web application development. The Jamstack approach has become more and more popular. So you have frameworks like React and Vue and things like that. And the way it works is that it can you can write your application, your UI, in the abstract and high-level language that's typically also in JavaScript, and then it has a step to compile that into a JavaScript and HTML application that can be distributed as a static website over, say, CDN or GitHub Pages, places like those. And so the browser downloads those so-called front-end, compiled front-end, and renders them, by running those JavaScript inside the browser. And if there's dynamic content in there, it's you typically create microservices or serverless functions on the backend. So so it provides the interactions that go with the front-end website. That makes the website look a lot more like an app, right? That's if you have a mobile app, that's downloaded to the device and then runs on the device and then gets data from APIs on the backend. So it's the same type of idea. However, this approach has been popular for the past couple of years, but people have also been finding problems with that. The first, as those websites grow more and more complex, the requirements on the browser becomes more and more, and also it becomes slower and slower to load in the browser. So that's you would see those Jamstack applications, React applications all ranked very low on Google, on Google ranking, because Google weights the first to action. That's so because you need to load all those web HTML and JavaScript and run them. So it's it takes half a second for the website to become interactive, something like that. So so that has become I think increasingly a problem. So the SSR approach, or the server-side rendering approach, is developed over the past year or two. It's specifically used to address this problem. So so the idea really is that most of the work that happens is running JavaScript in the browser, but we can also run JavaScript on the server, right? Why can't we just shift some of the JavaScript work to the server, and then have the server send the rendered results, the HTML DOM objects, to the browser in the streaming connection, and have the browser just render those, right? That's really can speed up the whole application, right? That at least that's the approach that React took, right? Because take advantage of the feature that the browser and the server can run the same JavaScript. So that's what's called isomorphic application, meaning that the developer only needs to write it once, and then deploy time, depending on the device you are deploying to, you can have the choice whether you're gonna send the whole JavaScript and HTML, the compiled artifact to the browser to render, or you can run it on the server and have the result streamed to the browser. So it's all nice and good. That's also something that we can support. But the thing I want to specifically show you here today is that people have then come to realize the idea of isomorphic application does not only apply to JavaScript, because guess what? In the browser, you can not only run JavaScript, you can also run WebAssembly. So, so there's a whole a class of modern UI frameworks that is written in Rust and allow Rust developers to write web UIs. And instead of having JavaScript to provide the interaction, it uses WebAssembly to provide the interaction. So meaning that you write the UI in Rust and then compile that into HTML plus JavaScript plus WebAssembly, and then have the browser download the whole thing to run it, right? So representative frameworks on that, including U and Percy. There's a bunch of very popular Rust-based front-end frameworks or web frameworks that's designed around that, right? So that's basically the background, right? So but since WebAssembly can run on both browser and server, so that brings up the question: can we run WebAssembly, this WebAssembly code that targeted for browser on the server to do server-side rendering as well? And in order for that to happen, we need a WebAssembly runtime on the server, right? So in this particular case, this WebAssembly runtime also needs to be able to handle network connection because it needs asynchronous network access because itself is running on server, right? And it needs to be able to communicate, it to be able to be managed by, say, a container framework like Kubernetes or Docker tools. So with all those features in place that we have developed over the past, I would say, 3 or 6 months, that we have, we finally have WasmEdge to have all the pieces together, that we can have a demo that shows an entire Rust-based web application that is compiled from Rust source code, and then it's deployed onto the onto a edge server, and then you have a browser on the other end to do server-side rendering, and you can also do client-side rendering. So this is the demo I want to show you. And if you look at this webpage, this is just a demo website that we set up. There's still some issues with it, but bear with me. So the URL I put in here is a repository that is an example for Percy. If you go to that URL, if you go to that URL, that's GitHub repository, you would be able to see how to run it. Essentially it is a fairly standard Percy application. Percy is a Rust-based web framework. You can compile this into something that can run in the browser, right? So if I go back here, yeah. So just to put the repository here, so this web application knows where to fetch the code, and then you say what type of application it is. Here we support Percy, and we support React, right? So we not only can support a Percy-based template, but we can also support because if you recall, the WasmEdge WebAssembly runtime also runs JavaScript, so it can run JavaScript-based isomorphic application as well. So it provides full support for Java frameworks, for JavaScript frameworks like React, which I will not demonstrate here. That you can play around with this website and see it on your own. But what I would like to mostly share, because that's one of the truly unique features here, is to support Rust-based web framework, right? So you have this example a website that's set up according to the rules, the the structure Percy has. And then, you select Percy as template. It gives you the build script that you can modify that, you can override that if there's things that you have changed in the template that you can make changes to the script, right? Now we say deploy. What it does is that it opens up a panel on the website that shows you, it is because this is a Rust-based project, so it's first, use cargo build to build this project into a WebAssembly target, right? It's built 2 WebAssembly targets. One is for the browser, it's using a Wasm pack that use the Wasm bygene to communicate with JavaScript, and the second is that it's use WasmEdge bygene and Wasm so that it can run on the server. It can run, it can open a HTTP server ports and to be able to listen to asynchronous network requests, right? So it's going to take I think perhaps a minute for it to build, but so it throw up some warnings. So that's obviously there's some this is the second pass of the build, right? So the first it builds a Wasm that goes into the browser. Second, it goes to builds the Wasm that goes into the server, right? So as you can see, there's things like the WasmEdge WASI sockets, so it's our networking library that allows the application inside WasmEdge to be able to open network connections, right? Okay, so it's have some warning, and then now it runs the server in WasmEdge, right? So this command, it runs the server in WasmEdge, and it shows you deployed successfully here. Obviously there are things that we could improve here. We could, because WasmEdge is fully compatible with Kubernetes, so we can have Kubernetes manage that. So we can have, nice DNS settings. So instead of using the port numbers here and all that, so, if I open that, you would be able to see a website, right? That's obviously this is, there's, very simplistic CSS, so there's nothing really to show here. But what I want to show is that we are getting to the place where it's more like Java in 2000, I would say, right? That's you would be able to deploy a full server or Node.js in 2008 or 2009, right? That's you would be able to deploy a full server in WebAssembly. Use write code in Rust and compile it into WebAssembly and deploy it in WasmEdge, and then have this have it packaged together and managed by Kubernetes like a container, right? Without any external dependencies. To run this server to that's a serve HTTP request from the internet, right? So for the if you're interested in how this is done and how to replicate the whole thing on your own system, we have a set of tutorials that we have written up. That's so if you go to the WasmEdge book, that's our main documentation site. You can the thing I have just demonstrated is the server-side rendering in Rust. So if you are using Rust to write WebAssembly applications, you can have you can choose a web framework. In this particular case, we choose Percy, right? That's and then you can enable server-side rendering in Percy, and that's this document goes through the whole process and walks through the code. That's a lot of this code is just copy and pasted from the templates, right? But that's if you're interested, you can go through that and read that, and you will be able to see that's that's how we did it, and you will be able to repeat it yourself. And the thing that I haven't covered, which actually is a nicer example, is to do the JavaScript, is to use React SSR. Like I said, one of the interesting features of WasmEdge is that it's not only runs, WebAssembly bytecode, but also runs JavaScript. That's we can use it as a Node.js replacement to run SSR backends or the front end or BFFs, the SSR functions for React applications. why do we do that? That's it's because if you want to use Dino or Node.js to run React backend, you probably still need to put it in a container so that it can be managed by Kubernetes and also provide safety and all that stuff, right? That's so that means you need Docker and then have Linux in it, and then have Node.js, and then have your application in it. But now with WasmEdge, you can have a fraction of that cost because because you don't need the operating system, and you don't need the the Linux container around it. You only need WasmEdge, and which is a lightweight and process-based container, and it can be directly managed by Kubernetes, and to be able to provide services for those SSR functions on the edge, right? So there's pretty comprehensive demos and GitHub actions, and you can see from this webpage, and it goes through the different modes of server-side rendering using React. You can do like static rendering, that's meaning that's it's everything's rendered on the server, and after it's completely rendered, it sends all the HTML and DOM objects to the client. Or you can do the streaming rendering, meaning that's you send a skeleton of HTML to the client first, and give the user a skeleton website, and then you stream over the content for each section. So from the user point of view, you would see immediately see a website, and then then the content in the website would be filled block by block, right? That'll be streaming rendering, and then there's a complete example for React 18, which is the latest version of React that would that's essentially is to use to in both modes, right? You can compile React into a client-side application and then have it run in the browser, or have it run on the server. And in this case, instead of running in the Node.js, we have it run in WasmEdge, right? So that's yeah. So obviously all those work are still early, but then as you can see, we have documentation, and we already have a demo website where where people in the community obviously don't abuse that, because there's no protection that is set up to protect resources on that demo site, right? But if you are curious, if you are interested to see how it works, just you are welcome to come by and try it out and give us suggestions how we could improve that, and also maybe adapt it to other front-end frameworks, because there's truly a lot of front-end frameworks there. So far we only had time to do React and the Percy, but there are a lot more JavaScript and WebAssembly-based frameworks that that's you can write highly interactive front-end applications. So yeah, that's the demo I want to show. So Tim, back to you.
Yeah, fantastic. Really fascinating and thought-provoking too. I've got a question for you later, if I can sneak one in, if there's enough time. Yeah, very interesting. Thanks so much. And next we're over to Haidai, and I believe he'll be doing the WasmEdge 0.10.0 preview. So whenever you're ready, he's ready. Okay, take it away.
Okay, now let's start. Today I'm going to do a preview of our next big version, 0.10.0. So I think we have 4 parts to talk about. First is the breaking changes and new features, fix the issue. Yeah, we have lots of fix the issue and some remaining things. So the first thing is that in this version, we support the tailcode proposal. Actually, it's very, I think it's very important things or something, because I believe most of the Wasm runtime have support this proposal. So that's our, we are trying to follow the steps just like the other Wasm runtime in this proposal. and we received lots of feature requests and some of the bug report about our WasmEdge component. For example, we do not support IPv6 in many functions. So if you are using IPv6, then you will get that lots of error message. So we will redesign and re-implement lots of the component in this WasmEdge function, including the IPv4 and IPv6 support. Also, we will just make the DNS name lookup function be robust, because in the previous version, someone found that you can send the zero terminated string as a domain name, and it make this function crash. So we will just add lots of tests to ensure this function is going to work. And also, in the previous version, we do not support the UDP related function like send to and receive on, and we will just enable it in this version. Also, in the previous version, we actually have the set socket option and get socket option function. However, the options do not have just one type, they have several types, and different types will require the different information. However, we just handle just one or two of them. So if the user is trying to use the complicated option, then you also will return an error. So there's lots of the since they will break the current WasmEdge socket. So after we release this version, we are going to upgrade our WasmEdge socket SDK, which you may just see the several demo in the Michael's talk. So here is our, I think it's our very big breaking change just in this component. Then about the new feature, the first thing is we released several of requests. They want to run the WasmEdge SDK in multi-threading. And before this version, actually we do not guarantee any thread safe. So if you are using the store manager, or you are using some configuration shared by several WasmEdge runtime instance, then it will produce some unexpected behavior. Actually, there's a lot of undefined behavior. However, in this version, we introduced thread safe in our in several components, including the executor. So the executor is just become thread safe now, and also the stack manager. So if you want to share the stack or share the store, we will have the mutex to make sure the cross-threading access is more safe now. And also, these thread safe features are all applied in C API, so you can use the new SDK to make sure the behavior is guaranteed. Also, we have updated the statistic timer, and it is also support the multi-thread execution. Then we also just expose more functions in the C API. For example, now you can just get the module name from the import object. This is a very basic function. However, because our previous use case do not find that we needed this function, so we do not expose. Then there are several developers come to us and talk about they need more information to do some job. So we just expose this function, and also we expose the module instance and lots of related function because that's too detailed. So I'm not going to share. I'm not going to read those function name here. Yeah. After the version released, we will have a very long changelog, so you can just refer to the doc. Then one very important thing is that we optimize the loading process in universal Wasm format. The universal Wasm format is that we will pack the native binary into a custom section in the original Wasm file. So when our runtime try to process or try to execute this universal Wasm format, then before it jump into the native part, it will just parse and construct the ASD from this Wasm file. However, it's just totally unnecessary because if we want to use the native binary, then we just jump into the native binary section and load the native binary section to execute. We do not need to construct all of the remaining Wasm part. So we will skip lots of function body in ALT mode if the native binary is fine to execute. If we find the binary is broken or is not support, for example, you compile this native binary from a Windows platform and want to use the Windows binary on a Mac OS, then it will report that the native binary is not compatible, and we will fall back into the interpreter mode to make sure the execution is still can run in that case. Okay. Then I believe this is the biggest feature in this version that we want to introduce the plugin system. If you use the WasmEdge TensorFlow tool before, you can find that if you want to if you use the basic Wasm function, you can download the WasmEdge CLI tool. However, if you want to run the WasmEdge plus the the TensorFlow or TensorFlow Lite function, then you have to download another tool called WasmEdge TensorFlow. However, we believe that actually we don't need to release lots of extension binary. Actually, we can just convert those extension tools into a plugin. Then we just need to put those plugin in a folder, or you can use if you are using SDK, you can have a help function to tell the WasmEdge to load specific plugin system. Then it will reduce the release process. We just need to release the WasmEdge core CLI tool and the WasmEdge SDK. The remaining extensions can be loaded just by the plugin system. So this is the biggest feature in this version. Then the WasmEdge process will be our first plugin. Just to mention it, that the WasmEdge process is an extension that allow you to code a native binary from the shell in the Wasm file. Yeah, this will become our first plugin. Then after we validate this plugin system is working, I believe in our next minor version, we will just convert the remaining extensions, including the WasmEdge image system, the WasmEdge TensorFlow, and the others. Yeah. So this will be the big things. Then we fix lots of the issues. For example, you can find lots of the circuit related issue. And so just to show here, and let's go to the final slide. And actually, we also reflect lots of the component and replace lots of data structure inside our WasmEdge. For example, we just remove the unordered map with the dense map and spiral map. And also we remove all of the usage of sorting exceptions in the CLI option component. And we do lots of things to, I believe, to optimize the data structure inside the WasmEdge to trying to get more performance improvement or to reduce the complexity of the WasmEdge. Yeah, so that's all of my 0.10.0 preview. Now let's get back to Tim. Thank you.
Excellent, Hade. Wow, a lot to take in there. Thank you. That was really, really good. And again, I have a question for you as well, which is good. All really great content. Thanks, Sam and Michael and Hade. That was brilliant. So we're about 8 minutes away from taking a full hour. So I believe it's now the time to do some question and answers. So if anybody, participants would like to fire away with some questions, please do. To any of those speakers, just go ahead and unmute yourself and go for it. And I see Hade's shared his slides there in the chat, if anybody's interested in that. Thank you so much.
Hi, this is Paul Dunham. I'm with Limelight. So we're looking at integrating Wasm into our Edge, and we're evaluating different sources for Wasm. Do you have numbers on like adoption rate or like who's using your tools? Or is this still all just open source that we're, I guess my question is it, how theoretical is it versus actual?
Yeah, maybe I can take this question. Yeah, that's well, we're actually working with quite a few CDN providers. If that's what perhaps that would be that could interest you. That's because there's in fact a lot of people are trying to use it in edge computing nodes, right? Be it servers on the CDN and or things like that. And the use case I specifically talked about, like the SSR, is I think one of the most important use cases on the edge cloud or on the edge network, right? There are a couple of those use cases, not just SSR for Jamstack applications, but also SSR for video, or SSR for metaverse, right? And SSR for games. You have Unity 3D, which have the same property, can do isomorphic applications. That's Unity 3D can be compiled into WebAssembly to run inside the browser, and also can run on the server. And and then on the server you need a WebAssembly runtime to execute those functions, right? So yeah, there's and we also work with all the leading edge management frameworks, like like in CNCF, there are at least 3 Kubernetes variations that are designed for managing either edge devices or edge computing nodes, right? KubeEdge, SuperEdge, and OpenYAWL. That's that we have integrated with all of them, and that we have published case studies with them. So yeah, there are lots of users and a lot of people doing experimentation, and I think we are still a little bit away from having really big production use cases, but we are getting there. So that's I don't know if that answers your question. There's lots of proof of concept and pilot that's going on.
Okay. Yeah, because we're entering into our own sort of POC and research and development phase. We wouldn't do SSR at the edge because a lot of SSR involves going upstream and having the edge nodes wait around for upstream to reply. Doesn't really work well when you're dealing with the massive volume of requests that come into a CDN. But there are a lot of other use cases at the edge, like, request, in Next.js, there's the whole routing architecture, right? So you can run almost everything that's not SSR and ISG at the edge. So the routing, synthetic responses, ACLs, WAF, all those sort of things.
Yeah.
So there's a lot of, we have a lot of interest in the edge, in the Wasm on the edge.
Yeah, we'd love to hear about those use cases and see how we can help, because as you know, we are the WasmEdge project primarily develops this this runtime, and we rely on the open source community to find use cases and tell us what are the features that we're missing. That's where we'd love to collaborate and see how to enhance our platform to support the use cases that you care about, right?
Okay.
Yeah,
that'd be great. Yeah, so you'll probably be hearing from us more in the next couple months.
Yeah, we look forward to it. Yeah. So.
All right, thank you.
Yeah, great. Thanks, Paul. Excellent. And anybody else, just feel free to jump in. Just unmute your mic and go for it.
I have to bounce. I have to get ready for my next meeting. But thank you, everyone.
Thanks, Paul.
All right, thanks, Paul. Yeah.
Bye-bye. Okay, so I might just jump in with a quick question. Actually, this sort of goes to Michael or Sam or both. I was just curious about one thing. Actually, Michael, in your demo there, I noticed that when you launched the button clicking there seemed to be persistent data. Could you just quickly speak to that? Is there some sort of persistent data storage when you recompile and relaunch that?
Actually, no, not yet. If we shut down the server and restart it, all the state would get lost. That's all the port mappings and all that. But that's so this is intended for a demo. But as you can imagine, there's because we have full Kubernetes support with WasmEdge, so our next step would be to have DNS domain mirroring and things like that, so people don't have to deal with the port number, right? And things like that, and have all those rules written into a database or in the Kubernetes configuration file. So when we restart the cluster, they would still persist, right? But obviously that would be then we need to think about what if someone comes abuse it and start like a million servers. What are you going to do that? So yeah, that's but that's more so at this stage we are technical proof of concept. That's what I have to call it. So to show people that this works. Yeah,
it's very impressive. It's excellent. I just was curious about that. And the other thing I wanted to just bring up, if there's other developers here listening, and just for the team in general, is that I actually listened to some conversations back in the last meeting, and I think there's still a really strong use case or potential proof of concept that is worth trying in relation to compression, because we have this this client and server as type relationship where we know that we can run essentially the same code on the client side, and if you want to call it the client and then the server side, I guess just for ease of explanation. The thing I think is interesting is, rather than just like a user viewing a website or those sorts of use cases as we've shown there today, I think another one is, think of it like an application where it might be collaboration on documents, or some sort of a project tool where there's like a master copy of some information, or like a model or some large data set, and then the users on the client side, for want of a better word, are able to make changes to that data without actually streaming or downloading, uploading. So thinking of that, if you had compression implemented, because now I'm seeing all these fantastic tools that are being made, and it's sort of leaning towards, if you could enable the data to be compressed and uncompressed locally, and then also compressed and uncompressed on the server, and I guess you could just talk in hashes in terms of, where you're up to. I think there's a really interesting project there to look into, where people on the client side can make changes to a data set without actually the bandwidth, the throughput, by actually just signaling to that side, do this inside that giant file, and it will go ahead and do that on the server side without the throughput, if that makes sense. I hope I'm making sense.
Yeah. I think there's lots of, because we are opening the domain of, writing servers in Wasm, because, I think in the past, Wasm has always been strictly an embedded framework. That's sort of, it is very useful that way, but it's also limits its usefulness because it's, you can run it as a standalone container. You can't use it like a container. You just you have to use it as an embedded function of some sort, right? So, but now we can run server on it and have it server managed. I think it opens up a lot more interesting use cases in terms of serverless, and and there's lots of use cases like you have just described, like compression, image processing, even edge AI and things like that. They can all tie together now. So that's what we are. We find it exciting for.
Yeah, it really is. Listening to those talks is really thought provoking. You start, the possibilities just open up. So that's really cool. Yeah. Anybody else got any questions? So thanks so much, everyone, for joining us. It's growing every time, so it's really good to see. Community is growing, and good interactions here on this community meeting. So thank everybody for joining. Please join us again next month, and bye for now.
Thank you.
Thanks.
Thank you. Bye-bye.
Bye.
Thank you. Bye-bye.